Hello everyone. So today we talk about this another problem. Okay, find minimum in rotated sorted array. Okay, so suppose an array of n length sorted in ascending order is rotated, okay, between 1 to n times. For example, the array nums is given something like this: 0 1 2 4 5 6 7 might become 4 5 6 7 0 1 2 if it is rotated by 4 times, 0 1 2 4 5 6 7 if it is rotated by 7 times. So that is what it is, like sorted array is there, right, and it is rotated, and we need to find the minimum in sorted rotated array. So that is what they have given here. Now given the sorted rotated array nums of unique elements, return the minimum element of this array. First thing, it is sorted, and second thing is rotated. Okay, so it becomes something like this after rotations: 0 1 2 4 5 6 7, something like this, rotated 7 times. If it is 4 times, so 4 5 6 7, then again 0 1 2. So there is something like a steep increase and then decrease if it is rotated by that. Okay, because it will be some two increasing elements will be there. From 4 5 6 7 it is increased, then again 0 1 2 it is increased. Okay, and we need to find the minimum, so it will be in the value 1. Okay, so after 4 5 6 7 it reaches 7, then at the whatever will be the bottom at the top will be bottom, there will be the element. Okay, we can start looking from there as well. Okay, so that is what, and return the minimum number of elements, minimum element of this array, and the complexity is they are expecting is order of log n. So let us try to understand the approach, and then we'll try to solve this question. So let us try to understand the approach. The approach is very simple. Okay, so we'll be having two pointers. One is L pointer, which is low, another point is the high pointer. Okay, and similar to the binary search, we'll start and seeing the middle element, we'll decide whether to go to the right or whether to go for the left in search of the minimum element. So first we'll be finding the middle element, which is L plus h minus L divided by 2. Okay, so this is just to avoid the overflow in integer. If we add them, it will become overflow, otherwise that's why we are using something like this, h minus L divided by 2. So suppose the indexes are 0 1 2 3 4 5 and 6. So here it will be 0 plus 6 divided by 2, which is nothing but 3. The middle element is this. Now we want to see that from where we want to go. So first what we will decide, that the element which we got, nums of mid, is less than, if it is less than this one, okay, then we'll decrease our head high pointer to the we'll bring it towards the middle element, towards here. Okay, because we can be it is possible that the element which we want to find is starting from here and up to this point it will be there. Okay, so that's what it is going to depict here. So that's why here in this case we'll be checking that nums of mid, if it is less than nums of high, then we'll simply update our high to mid. Okay, so mid is this one element. Okay, we can call that as m here. So yeah, let us call that as mid only. I have written 2 times there. So mid is this one. So we'll update our head from high from there to here. So we are not going to look into this part, we are just forgetting this part. Okay, and then the part is this one. Okay, now again we'll do the same thing. We'll find the mid, and mid is nothing but this one, because 3 by 2, which is 1.5. okay, 3 by 2, which is 1.5. yes, and then we'll be looking to here, so it will be this one. Okay, not this one, it will be this element mid, because 3 by 2, and it is going to be taking the always floor of integers, so it will be 1, and 1 is this element. So again we'll be seeing that m is less than h. No, it is not there. So in this case what we'll be doing, we'll bring our low to mid plus 1, so it will be at this position. Now again we have this one and this one, so we'll be again doing the same thing. So 2 and 3 is there, so what we'll be doing, we'll be writing 2 plus 3 minus 2, which is 1.5, something like this, and the middle element. So 3 minus 2 divided by 3 minus 2, which is 1 divided by 2, is 1.5. Then it will be something 4 by 5 by 2, which is 2.5, which is nothing but 2. So this is the middle element 7, and again 7 will be checked. Is 7 is less than mid? No, it is not. So when again increase our L from here to here, now both of them are pointing in the same positions, then again L will be increased to L plus 1 because it is matching, it is not fulfilling this condition. So L will be increased and will be reaching here and will be coming out of the loop. Now again H is pointing to the minimum element. Okay, high is pointing at the minimum element. We are just going to return the element which is nothing but nums of H. So this is written, this is going to be giving us the middle element. Okay, not middle element, this is going to give you the lowest or a minimum value. Okay, so this is the approach. Now what you can do, you can try to pause the video and try to write the code by yourself by looking at the solution, looking at the approach, or I'll write the code for you. So let us start writing the code. So in this we'll be creating first we'll be creating low, which is nothing but 0. Okay, then we'll be having mid. Okay, I'm calling M, and then we'll be calling high, which is nothing but nums dot length minus 1. Okay, so this is simple at high, mid and low. Then we'll be running our while loop, while mid, okay, while L is less than equals to H, low is less than equals to high. At that many time we need to run, and mid will be writing mid equals to low plus, and why we are doing this, just to avoid the overflow, H minus L divided by 2. Okay, now we'll check if our nums of M is less than nums of H. Then in that case what we'll be doing, we will be bringing our high to mid. Okay, and in else condition what we'll be doing, we'll be bring our low pointer to mid plus 1. Okay, and then at the very end what we'll be doing, we'll be simply returning the nums of H as we have seen in the approach. So this is the simple code. Let us try to run the code here. So it will be successfully accepted. Now just decrease this and let's try to submit the code. So it is successfully accepted. So that's it for this video. The problem was very simple, but it just needed the right ways to solve this problem, and the complexity, as we discussed, as expected, we have solved in the given expected, which is log n time. Okay, binary search. So that's it for this video. We'll meet in the next video with another such problems. Thank you guys for watching.